Hi everyone. Today I want to explain this paper. It's titled "Real-Time Multimedia Face Detection Using YOLO version 12s based on the YOLOv12s datasets." The introduction talk about the face detection, the critical of for security and supervised and biometric identification. The main challenge that faced us achieving high accuracy with limited hardware, especially for small faces and varying lights condition. The solution, leveraging the YOLO architecture for the efficient real-time detection. We focus the evaluation the YOLO version 12s architecture against the YOLOv12s datasets benchmarks. The problem statements and the objective of this paper goes to investigate the trade-off between detection accuracy and the computational cost on the consumer-grade hardware. The key objective conduct through the survey of the YOLO version 12s or the YOLOv12s datasets. Perform the controlled comparison with the YOLO version 8s baseline. Test real-time performance on the conventional machines. NVIDIA GTX 1015. The methodology of this paper and datasets we used, it's YOLOv12s scaled this to 32,000 images with 393 image labeled face. It includes extreme poses, correlation, and varying lighting. The difficulty, it's the faces, small faces. It's less than 50 pixels, making it recognize just detection algorithms. Splits the datasets for training and testing between the 18 for training and the 10 validation and 10 for testing. Methodology architecture, the YOLO version 12s. The backbones uses CSP nets for strong feature extraction and the gradient flow ideal for small faces. And we use the NIC features primed network, path aggregation network PAN for the multi-scale feature fusion. The head of the architecture is free design to capture the strong gradient singles. Optimization, we use the employed mixed precision, AMP, and heavy augmentation. The experimental steps, the hardware we used for training, the GPU, that's NVIDIA GeForce GTX 1015, 3GB VRAM, and the CPU Intel Core i7, and the RAM, it's 16GB. Software environment with Python and PyTorch and CodeApp because we training in the GPU, not CPU. We use the ultralights YOLO and training config 100 epoch with batch size 8 and learning rate 0.001. The result we get for this paper is the overall, it's MAP 76 and the precision 84 and recall 66. Training scalability, steady coverage, and low variance and validation lose over the final 10 epochs. This table for comparison between the models. The conclusion, the summary, YOLO version 12s proves to be a reliable system for face detection outperforming the YOLO version 8's baseline in the recall and overall accuracy. Impact: the enhanced backbone and anchor face head provide better the handling of small faces and complex skins applications, ideals for surveillance and system and smart classrooms where continuous monitoring on the consumer hardware is required. Thank you for listening and have a good day.